Welcome back for our first speaker session. This will, I am 100% sure, be a very, very interesting session. We have very interesting and inspiring initiatives that will be presented from Australia, from Europe, and from the United States. We will hear about a variety of different concepts for industrialized construction with a little extra attention to customer focus that we think is a key to success. So first speaker is from Australia and New Zealand actually, Daryl Patterson, industrialized construction consultant and advisor with many, many years of experience from Lend-Lease. So, very welcome, Daryl.
Good morning, everybody, and thanks, Jyrke, for the opportunity to be here. It's great to be amongst such an esteemed company. So I'm yet another one of the many recovering architects in the room somewhere on a 12-step program. But I haven't practiced architecture. I've spent the last 30 years, as Jyrke said, working for a global, vertically integrated business some of you may have heard of called Lend-Lease. And the first half of my career there was very conventional. It was the usual construction management and property development sort of stuff. The second half, highly motivated by a number of factors, I really set out to change what this industry is about and how we do our work. And I was very fortunate because in that 15-year period, Lend-Lease opened the checkbook up for about $200 million worth of initiatives. But beyond the money, I got to work with some really fabulous people, and I'm pleased to say there's some of those people here in the room today. The ball got rolling back around 2009. I was looking at lots of different materials and systems and hoping for something that could deliver cost competitiveness and an uplift in quality, which were two of the big issues staring us in the face back then. And the winner of the process that we went through was cross-laminated timber, or more generally, mass timber construction coming out of Europe. The rest of the world wasn't really doing anything with mass timber at that time, and so we had to go through a very expensive process to bring the technology to the Australian marketplace. Considerable amount of R&D and product development. And most of that product development was comprised of burning wood, because you have to demonstrate, what the result is of setting fire to timber. And you certainly couldn't trust the Europeans to have burnt it properly. We built, first of all, a 9-storey condominium building in Melbourne. I was very happy with the outcome of that building, and the reason I was happy is the cost of it was only 3% greater than a conventional building. And why I was happy with that is I knew from the way we were learning about the material, over time it was going to get cheaper and it was going to become highly competitive. And we went on, we delivered 22 major projects around the world using cross-laminated timber, including quite a few projects up here in the United States. This project here, this is an office building in Sydney. It's probably one of the most successful buildings Lend-Lease has ever delivered in terms of profit. And I should declare I no longer have any affiliation with Lend-Lease, so please don't go and trade the stock based on anything I have to say. But this project here had a profit margin in excess of 40%. And if you know anything about the development industry, you'd know that's actually not the norm. It also won design awards and accolades. It was oversubscribed by tenants. It was oversubscribed by investors. And so when the time came to develop the block of land next to it, it was a very obvious choice. We simply wanted to take this building and we wanted to replicate it on the next site. And so we briefed the architect on that, and he responded, "I don't do copy-paste." So what he gave us instead was this building. And it seems like he met the brief, because at first glance it is copy-paste. But in fact, I can assure you there's more than 600 fundamental design changes from one building to the other, and none of those were driven by any sort of technical requirement. They're purely driven by the ability to be different for the sake of being different. And I don't call out that architect. He's a very fine architect with a great practice. I'm making this comment because that's the state of our industry. Even when it is purely logical to repeat the same solution, we go out of our way not to. So if we wrap up this chapter with some insights on that experimentation with a new material, I'd have to say, and this applies to mass timber or any product, including 3D printed concrete, no matter what your choice is, one material alone is not a game changer economically. It may be very helpful for improving things like sustainability. It may have some impact on cost, but no single material is the answer to all of our problems. I've used this line so many times, you know, we keep repeating these buildings, the cost's going to go down. Well, the fact is, if the buildings themselves are unique and the teams that deliver them are unique, that does not happen. We are actually telling ourselves a lie. And almost everybody in the industrialised construction space is in the same space of telling this myth to people, and they don't realise that we're not going to unlock these savings unless we really think about how we start driving some consistency. On a positive, you know, we know if we manufacture the structure, we unlock the ability to manufacture the rest of the building, because we're now playing with, you know, marvellous tolerances of plus or minus 1 or 2 millimetres, and we know we can't achieve that in the field. So it's well worth doing this kind of thing. And so here's the thing, if you're not making money out of a material, double down. So we went into a vertical integration with that material, raised some money out of the corporation, about 50 million to be precise, and set ourselves up a state-of-the-art factory. And you know it's state-of-the-art because the machinery came from Germany. Apart from processing CLT, it was also intended to manufacture pods like the one you can see in the image there. In fact, that was pretty much the only pod it made because it was very consumed by manufacturing CLT. This building produced some excellent projects. And 4 years later, we closed this factory down, sold the equipment for cents on the dollar. So there's a lot of talk about vertical integration in the industrialised space. And it makes sense for the reasons we heard about earlier. You do gain control over the stakeholders. But I think what happens, and I say this with having lived in a vertically integrated business for nearly 30 years, is that we underestimate the amount of complexity that we bring on board when we try to vertically integrate. And we hope that that complexity is going to be offset by margin. And that is not always the case. And so we need to proceed with caution. I'm not saying don't vertically integrate, but you need to be well aware of the scope of complexity that you're bringing in. And almost contradictory with that, we also know we need agency over the design process. Otherwise, we will not unlock the efficiencies that we're trying to bring forward with our industrialised solutions. So the conundrum is, how do you have agency while not necessarily vertically integrating the design roles and the management and the client obligations? And there are ways to do that, and they'll be different for each situation. It's worth thinking through. Finally, you have to ask, what was that business? What was that factory? It had no product. It had no systems. It had no platform. It had no standard details. What it did whenever a customer came to it is it said, show us your design, we can make anything you want. And you hear that refrain from some people hoping to be in the industrialised construction space. We'll build whatever you need. And if you examine that, what that business was great equipment and smart people. And what that is a custom fabrication shop. And that's fantastic because it can make beautiful things, but it can't do it cheaply. It's a very premium service that you've created. And there may be a market for that. There may be a niche opportunity that someone wants, but it wasn't something that Lend-Lease wanted. Now, spinning up factories is a pretty complex endeavour. You don't do it lightly, so we decided we'd do two at the same time to be efficient. And for maximum efficiency, we put them 1,000 kilometres apart. This factory was pretty straightforward. Its only job was to make bathroom pods. We weren't trying to reinvent the pod. These have been done many times. Everybody knows what they're about. And these were only for consumption into Lend-Lease projects, so pretty straightforward thing. We looked at the designs that Lend-Lease was selling to the public, and we said, you know what you need? You need a large bathroom, you need a small bathroom, you need a left-hand version of it, you need a right-hand version of it. That got us to a business plan that said, here's 4 typologies you're going to make. We wrote a business plan any Stanford MBA would have been very proud of. We took that through the entire business. We got it signed off by our customers internally. That was very important for us. We wanted to know we were delivering the product that they wanted to consume. And then we set about running this business. We got through its teething problems. We went from very poor units to very good units. And by the end of year 1, we were making 8 different bathroom typologies, followed by year 2 with 16 different bathroom typologies. And in year 3, the pattern was broken because it wasn't 32, it was 38 different bathroom typologies. And there'd been some extremely robust conversations with the design team on the way through as to why each new typology was required. And needless to say, we'd lost a lot of those arguments. And so the insights I'd play back there is, unlike the first factory, we now have a factory that does have a standard product. However, we're doing very small batch runs because of those typologies. We actually manufactured 10,000 bathrooms through this factory, which is not a bad result over a 3-year period. And if we'd stuck to the 4 typologies, you can see the sort of batch scale we would have had. However, what we were delivering is batches of 50, 100, 240 here, 30 there, never to be repeated. And that really limits the effectiveness of this approach. I think we've experienced this. If you're not a recovering architect and you're still in denial about your addiction, right, you're really going to struggle with this idea of standardised products. You know, this probably should be in red and underlined and in bold. And it's a bit like you've converted to vegetarianism and you've had a conversation with your cat and you've asked them to convert as well. It just doesn't go well for any party involved. And I think this is a point that we seem to miss. There is a lot of focus on all the other factors that are qualitative: sustainability, defects, safety, schedule, and these are great outcomes. And this factory produced amazing results on all those qualitative factors. Everybody loved the bathrooms. They were very high-end. However, they were cost comparable to built-in situ bathrooms. There was no cost advantage. At the end of the day, the corporate accountants came through and said, we're tying up capital, we're tying up management focus, this is our non-core business, shut it down or sell it. And that's what happened. So now we get to about 2015, 2016, we changed gears a little bit, the checkbook got opened quite a lot wider, we're now playing with about $100 million, and I got appointed Chief Product Officer for digital because I know absolutely nothing about digital. We had taken a lot of advice around the world at this point in time. Could you cue the first video, please? And we thought, and I still think, that the industry needed a platform that could take us from concept design to manufacturing. And we wanted to bring all stakeholders together around the one platform. And we wanted to go far beyond what we could see BIM doing for us today, and we really thought that digital twins were the right approach for doing that. And the video playing now is a digital twin of one of those timber buildings I showed you earlier that we built actually after the project had been completed. And this compiled many, many BIM models, many of the fabrication design models, and also a huge amount of other data around supply chain and costs and performance and other factors. And it was a great model, and there were all sorts of things you could do with it. The problem with this model and the 3 or 4 others that we built is it cost about $200,000 of labour to create it. And so that took us into a second direction. If you could cue the second video, please. And we thought, what we've got to do here is we've actually got to use digital capability to automate the design process. And to be clear, this is not a design configurator, and it's not parametric design. It's actually a procedural approach to encode design rules to have the software generate all of the building at a manufacturing level of detail. And so what you're seeing in the video is about LOD 450 manufacturing ready models that have been produced entirely by the software. So there's no drawing, there's no selection of components by a human. I want to qualify this to say we only did this in structure, and we only did this for mass timber and some precast concrete fabrication. And the reason for that is, at a point, we realised we were staring into the abyss. All right? We'd put nearly $100 million into this effort, and we had some of the best people we could find working on it. And a realisation was dawning that this thing was enormous, and it would continue to consume an unlimited amount of money. And you had to ask the question, you know, was the juice worth the squeeze? And it really didn't seem to be. And I feel like we also lost direction part of the way through here because it became more about, can we automate consultants out of the role of being involved in a project rather than creating that digital twin and that platform? And if you think about the cost of consultants in a project, then it really doesn't make sense to spend this kind of money to eradicate them. Although the one advantage is you get to stop them changing the bathroom types. So perhaps sacrosanct, given the location. But I guess the insight here is digital is critically important to what we are trying to do as an industry. It's essential. Everything that people are doing today with some of the amazing products we're seeing will be part of our landscape somehow as they mature. However, unlike other industries that digital has disrupted, I don't think we're going to see the magnitude of cost impact from digital that, say, film processing saw. And the reason for that is so much of the cost stack is obviously in the physical materials and in the labour required to assemble these things. Not to say we shouldn't continue to very much embrace digital and do some interesting things here. Finishing on the last thing I wanted to share today, underneath the digital team, we ran really a physical team as well. And they were focused obviously on where do we get a kit of parts from and how do we develop that. And this was a bit of a multinational approach. We had a team here in the Bay Area, we had a team in Sydney, and some other people scattered around the world, all trying to work via Zoom meetings. Fantastic way to collaborate on designing products. But I would say in my time at Lendlease, this was some of the best work we ever did. And where the focus went wasn't actually on the components, it was in how they were interfaced with one another. And we realised that beautifully manufactured components could come to an assembly site and still be painfully slow to assemble and still involve lots of skilled labour to do the job. And so we really thought about how can we take these components and allow them simply to click together with the least amount of labour and skill required. And if you could play the video, please. We actually had great success. So in some of the structural connectors we developed with some really good industry partners, we came up with a way of assembling buildings where you didn't need to do any survey, didn't need to do any measuring, you could simply push the components together. And you'll see in a moment, in this example here, this is all that's involved in putting a column into a building. It's simply lowered down with the crane, and once it reaches the bottom of the connector, the job's finished. That's it, the column's in place. However, we can also insert this bar, unlock that connector, take the column away, and there's our circular economy at play, right? We can reconfigure this building, we can reuse that component with no destructive work required to remove it. And the real story here is that this is a labour throughput exercise. So when we start doing time and motion studies like this one, we see a minimum of a 10x improvement in how labour is being used, and for some of the connectors, a 90x improvement. There's also a great financial story with this. We sold this IP. We were never the manufacturers of it. We were always interested in developing the solution and finding global supply chains for it, and that turned out to be a pretty lucrative opportunity. So the insights from this, I would say, the parts are commodities. The IP opportunity is in the interface between them. And if you're looking for something to invest in, I feel like this is a very rich territory that is not yet particularly well tapped to start thinking about how we bring these things together. It's also quite complex work to do. Obvious insight, I think the labour unlock potential from smart connectors is beyond anything we've recognised before. If we can get 10x to 90x improvements, that really is a game changer in terms of what we can do with this industry. So that's 15 years and 15 minutes. Where do we go next? We're at an academic facility, so of course it's appropriate to give you a formula. Don't worry about understanding the formula. What it represents is a law, Wright's law, which applies to manufacturing. And Wright's law is quite old, and it's extremely accurate, and it's been applied many times. And it's very simple, and it basically says if industry is given a widget to make over and over again, if you double the production of that widget, industry becomes very effective at figuring out better ways to make it. And two consequences happen. Quality goes up, cost comes down. Those are phrases that don't happen in the construction industry, and certainly not together, right? So I think we need to think about Wright's law and how that applies to us. And so we have this doubling of a batch size that yields an uplift with each and every doubling. So it's not a one and done, it continues. And I've just shown you assembly logic that says if we can apply smart connectors, we have a way of taking out the cost that follows on from making those efficient components. So how big is the prize? Well, Wright's law predicts that you can see a saving of circa 20% in cost with each cumulative doubling effect. And we've talked about the 10 to 90x throughput. So my prediction is if you followed this approach, if you actually rigorously applied the logic of a kit of parts that you used in cumulative doublings, and you did that for about 10 years, we would halve the cost of construction globally. There's an obvious problem with what I just said, and most of you have already thought of it. Where does the scale come from? You might get lucky. A customer might walk through the door that has some tremendous pipeline where there's many things of a repetitive nature. I thought that had happened to us one time in my career, and then somebody ate a bat. I'll just finish on this. I think there's an answer to how we unlock scale through this example here. This has been in our lives for 25 years, and it's a story of interoperability. It was created by 6 fierce competitors who got together and said we need an industry standard to unlock how devices can work together. And it blew the doors off 2 things. The consumer experience, we could suddenly mix and match so many devices without any hassles. And for suppliers, they could suddenly reach enormous markets because they weren't constrained to making a product for just one other product. And I think this is something we need to start thinking about. Whether we're ready to do it as an industry or not, I'm not sure, but I'll leave it with you as a challenge for the future. Thank you.